Hey, ecology students, it's Dr. Welch, and let's start off Module 1 on the Chapter 1 material with a definition of the discipline you're about to spend a whole semester studying, and that is that ecology is the scientific study of the relationships and interactions between organisms and their environment. Much of what we're going to do this semester is to use environmental problems, environmental case studies as a way to explore the different topics of ecology. And sometimes we'll explore topics of ecology and then go find an environmental issue where those topics are relevant. So in this first module, we need to be able to differentiate between ecology and environmental science. So by definition, environmental science is the interdisciplinary study of the natural and man-made world, and it emphasizes the humanities, including sociology, economics, and political science. Ecology as a discipline lies at the intersection of genetics, physiology, behavior, and evolution, and it can be studied on a variety of spatial scales, different scales of biological organization. As I alluded to in the first day of class, we're going to work on scaling physiological processes all the way up to the organismal, and in some cases all the way up to the ecosystem level. So even though it is this very broad, overarching discipline, similar to evolutionary biology, that relies on the underpinnings of physiology, genetics, evolution, and behavioral studies, you can study this discipline on a variety of levels of biological organization. Sometimes you're going to feel like you're riding a yo-yo in this course. I'm not kidding. We're going to be on the cellular level, then we're going to jump up to, the ecosystem level. And at times, students look at me and go, "Stop it, I'm getting dizzy." When you look at how the discipline of ecology emerged over time, you can trace it back to natural historians, to people like John James Audubon, studying the relationships between species and their habitats. Then it became very mathematical, and you're going to see a lot of graphs. We're going to do a lot of calculations in this course. You see the integration of human demography, and in particular biometry, which is I got tongue-tied, a statistical approach to studying biological systems. And then ecology was being used to answer questions, applied problems, the spread of disease, the growing of crops. So it has very tight historical ties to both medicine as well as agriculture. When you expand this out, you can trace the roots of ecology all the way back to the hunters and gatherers. You needed to know where the species was in terms of cues in the environment to find your food sources. That was the secret of success to both hunters and gatherers. It has interesting ties to the fear of pests and plagues with the Egyptians, the Babylonians, and the Greeks. And here I am speaking about the biblical plagues, to which at that time there was this thought that the biblical plagues were put upon people by a supreme being. And instead, what we know today is most of them are traced to things that were unknown at the time, such as viruses, or, getting back to our course, changes in the environment that would bring on a plague of locusts. So interesting tie there to the Egyptians, Babylonians, and Greeks. Again, the math came in heavy in the 17th century, and it's very similar from this point forward into what influenced Charles Darwin in the emergence of his theory of evolution by natural selection. Here comes Thomas Malthus' essay on the limitation that resources can place on human population growth. In the 18th century, here came a better understanding of disease with the emergence of germ theory. And then there in the late 18th century and moving into the early 19th century, we get the shift in paradigms that hopefully you've heard about in other courses. And this shift of paradigms led to what we refer to as the modern synthesis in the biological sciences. The shift of paradigms was from control of the earth by a divine being more to the struggle for existence that is set up by natural resource limitations. That competition drives a lot of the biotic interactions that shape ecological relationships. And so, there was this shift between species being perfect and permanent, and any kind of extinction or change in that species was brought about by divine intervention. Two, what we know of today is that species extinction comes about by competition. Or drastic changes in the environment that lead to extreme competition for resources that puts a species on the brink of extinction. And we're going to talk about the role that people play in species extinction throughout the semester as well. Looking at more specifically the exact timing of the founding of the science of ecology, there were enough people studying these interactions that the Ecological Society of America was founded in 1915. It just celebrated about a week ago its 100th anniversary in Baltimore, Maryland. Unfortunately, I missed the meeting and the yummy crab cakes. But one thing I want to show you before we leave this photograph, look at how many women are in that photograph. And keep in mind, you're talking about 1915. This was one of the first scientific disciplines that was very friendly towards women scientists, and it remains true to this day. The other thing that's interesting, I don't know exactly how many people are in that photograph, but I would venture to say it's less than 100. And this year in 2015, the Ecological Society of America has close to 10,000 members. So we're a big group. In terms of when ecology came into the college curriculum or even into the high school curriculum, and particularly when a major of ecology was formed, that happened after the publication of Fundamentals of Ecology by the Odum brothers. Eugene Odum was an ecologist. Howard Odum was an economist. Both of these guys were, well, Gene Odum was at the University of Georgia. Howard was at Duke. You're going to hear a whole lot about the birth of ecology coming out of the Southern schools. And in particular, your really top-notch Southern schools like Georgia, North Carolina, Duke, and some others that we're going to mention along the way. There's also a very strong influence of people out of the University of Chicago. So it's very much, if you will, an East Coast science that then spread westward. And the University of California, Berkeley, and Davis became birthplaces of the discipline of ecology. But they wrote the first ecology textbook. It was published in 1953. But you did not see ecology as a formal discipline until the 1970s. And the person I did, Dr. Ed Buckner, who I did my PhD with, Ed got his college degree in the 50s. He was a practicing ecologist, but his degree was in forestry. So it's a relatively young science. Evolutionary biology is actually a little bit older than ecology. And it's a science that draws people that are very conceptual, very synthetic, and like to see how the whole world fits together, if you will. What brought ecology into the living room of the average citizen, and a good way to wrap this back around on itself with the ties we're going to make to environmental science, was Rachel Carson's publication of Silent Spring in the 1960s. And that was a book where she was warning that the use of pesticides was causing population declines in non-target organisms, and she predicted many of the human health impacts that we now associate with endocrine disrupting chemicals, and many of which are pesticides. But she used the word ecology throughout this book, and it was more of what we would define today as a study that would fall under the realm of environmental science. So this brings about this great quote by Charles Krebs, that ecology should be to environmental science what physics is to engineering. The laws of physics are applied in the design of the airplane to be able to make it fly. So the rules, the laws, the theories of ecology are applied to environmental issues to help correct those issues and to mitigate their impacts on all populations and the interactions of those populations. And the last thing I wanted to leave you with, this is a rapidly expanding field at both lower ends as well as higher ends of biological organization. You have molecular ecologists all the way up to folks studying biosphere dynamics, where ecology transitions into atmospheric chemistry, atmospheric physics, and meteorology. So it is an enormous field. You can find an area that you think is interesting. And the other thing, to either ease your mind or to know that misery loves company, the Ecological Society of America is highly involved in undergraduate and graduate biology and ecology education reform. And it's why you have me to either thank or to curse for some of the innovative projects that we're going to be doing this semester. I've been very active in ESA's education group for going on 10 years now. We're the movers and the shakers in undergraduate biology education, and I hope you appreciate some of the stuff, some of not only the competencies that you're going to master this semester, but as well the ecological content.